15 to 17 years of experience, and about most of that is in the US, over 15 years in the US. And most of it is in the BI space. Okay, so I've been working. Initially, I worked as a Cognos consultant and architect. Blah blah blah.
Business
Then I
intelligence you're talking about, right? Business intelligence.
Yeah,
You're talking about business
intelligence. Yes. So and then I've also worked on ETL tools like Informatica and Ab Initio, and obviously databases also. Currently, my work is mostly on the delivery side. I don't do any development, but I handle development teams, like both in India and also in the US. Like the company I'm working for. Now I'm just trying to kind of upgrade some of my skill sets, and that's why I want to get into understand big data, the basics, the concepts, the terminologies, the different types of these applications or whatever modules that make up big data, stuff like that. I am not looking for a job as a big data consultant, but I'm looking to basically get a good feel of big data so that I can use it in my day-to-day work, working with people.
Yes, exactly. Knowing only this big data, not only for today, definitely this will crack your future in the next few days.
Exactly. I mean, that's
all the things this is getting involved. This big data is getting involved in all the technologies, whatever you may use, right?
Yep, that's right. So, Sindhu, can you also give me? Is it just going to be you and me on this? Okay, that's great. So, Sindhu, can you also give me a background on you?
Yes, sure. I'm currently working as a technical architect in one of the MNC. So I do have experience. Currently, I'm working for data analytics. I think you have heard of a course called data science. The next course for this Big Data Hadoop. So I deal with this big data basics or Big Data Hadoop course as long as this data science course as well. But as a complement to this Hadoop course, I can just, I think you have already know the business intelligence very well, right? Like reporting tools and how you do model building and all those things, how you, that model building, everything right? Like in R, they do some data science and all those things. We do all those stuff right now. I can just add that complement to any other students if they want. Yeah, that's it. And yes, come to my experience. I do have a Hadoop experience of 4+ experience. Not in entire Hadoop. Like when we have started our career, we started with a POC kind of thing in Hadoop, and we started going on the production side. And I do have a fully Java experience, and I'm currently working for HCL Technologies. That cannot be revealed actually. And yes, coming to this course, this is only I deal with a big data development course, and as part of this Big Data Hadoop course, I can just add 30 to 40% of administrative course also. Why? Because this is a hard course. No one knows everything in this particular thing. When a company recruited one person, they just need to develop their own clusters. Because of that, I have just added some cluster setups and daily maintenance, the health checks and all those things. Some administrative commands also I can just introduce to you. If you want any other extra information, we'll just add it to the course. Okay?
Yeah. So Sindhu, what now when we talk about big data, right? Obviously, Hadoop is one of the main technologies. What are the other types of technologies when we talk about big data?
Yes. We can take any other technology like SAN, the storage area network, SAP HANA. We can just integrate it to any other analytical tool after storing the data into any other particular storage devices that you have. But the problem is that the commercial license, we need to pay for that particular tool. That's what the problem. That's why the hype comes into picture for Apache Hadoop. You can just use any other tools which you are currently using. But the thing is, you just need to integrate everything into as a single tool. That to the commercial license you need to pay.
So Hadoop is basically open source, right?
Yes. In that
And
also
the
there are
other,
distributions are there. But the thing is, you can work with this Apache Hadoop, whatever that is there in a pure version. You can just build your own clusters and you can just go forward. But you want some customizations in that, some UIs in that thing. You want to see how many jobs are running, what is the status of each and every job. There is no support in Apache Hadoop to see it from the part. Only the commands are available, you can just see, but in case of distributions, there is a support is there.
okay. So I'll tell you what. Let me also give you this thing. When it comes to big
Yeah.
data, my experience and my knowledge is pretty much zero. Okay. I mean, I know Hadoop, but in terms of just having heard terminology. So when you talk about SanDisk and all that, I mean, so that's why I'm asking you, when we talk about big data, what different types of components or applications or systems or classifications do we have there? You know,
Into
when you
this
say big data,
Hadoop.
is it always Hadoop or is it something else also?
No, no, no. Actually, that's what the introduction course to be given to you on big data. Otherwise,
Okay.
definitely they'll start with Hadoop only. As a
Mm-hmm.
big data Hadoop, it's just not a course actually. This big data is a separate problem that the organizations are facing, and the Hadoop is a solution, one of the solution giving for big data problems.
Okay.
This is
Cool. All
one
right.
of the
So
solution. Yeah.
no, that's fine. So good. So I'll let you kind of continue. Can you just show me like briefly what topics will we be covering in the big data basics? So I know what to expect.
Yeah, yeah, sure. I'm just opening that. Yeah, simply these are the components that I'm going to cover.
Mm-hmm.
The introduction to big data and Hadoop, installation of clusters of single node and multi-node, and the architecture ecosystem components, HEFS, MapReduce, Big Scoop, Zookeeper, and OZ. And what happened? Yeah.
Cool.
Hive, Impala,
Mm.
Flume, NoSQL databases. Yes, one of the NoSQL database, HBase, introduction to the second version of Hadoop, MR version 2, and the integrating projects. So meanwhile, also we can just discuss some of the projects, not after
Okay. And
completing the course.
awesome.
Yeah.
Okay. Cool. And
And
one session is normally what, 1 hour or less?
sorry?
One session normally tends to be 1 hour or what?
Yeah, yeah. It depends actually. One particular topic will not end in 1 hour session, right? It may
I'm
continue to
sure.
next 15 or 20 minutes. It depends actually, depends upon the topic, depends upon the flow that we are going. I can say that it's a maximum one and a half hour.
Okay, great. Cool.
Yeah, on a weekends, right? If you have a time, and actually I'm very much free in the weekends, we can go 2 or 3 hour sessions. So that when we have a Hadoop installation or any integrating project that we are discussing, then
Mm-hmm.
definitely that needs a 3 hour session, so that it will complete in a one particular day. So that you
Okay.
will get a clarity on the topic that we have discussed. I too.
Okay. Cool.
Okay. So
And
if
Sindhu, will you also be providing some kind of literature or material for me to kind of go through and all that?
yeah, yeah, I do have a soft copy of entire course material and all the things. I've just shared to the Zoom training candidates back in the content writers. They'll just
Mm-hmm.
do some modification to that content. They'll share it to you, okay?
Okay.
And
So
meanwhile, if you want,
you don't really work for Zoom, right? You're just like kind of a consultant or something for them, right?
yeah, 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 the same thing, the online trainer only partner kind of
Mm.
thing.
Yep.
So if
Cool.
you just want the entire course content, what I'm going to cover.
And again, Sindhu, I mean, mine is a little more condensed version because we want to go through all the topics, but I don't want to go to the level of detail as a developer, like I told you, right? It's more getting the understanding of the architecture terminologies and all that more than
Yeah,
basically the
that's what
coding.
actually heart of Hadoop. If you just
Right.
have any
Okay.
client interaction or any kind of thing, definitely they
Hmm.
won't focus on what programs that you're writing or what kind of flow that you're going. But the only
Mm-hmm.
thing is what's the architecture that you're following. Like
Okay.
the cluster, if we just say, what are the components that you're taking care to do some monitoring kind of thing and all this stuff. The the heart of Hadoop is like architecture, the features that it provides, how it provides all those like data loss and all those things. Okay, we'll
Okay.
just go through all those things. If you just
Sure.
want all those things, actually these are useful for a developer that I'm showing.
Yeah. No.
ठीक है,
Fine.
then,
I mean, I'm sure. Okay.
yeah,
Cool.
yes. In your mind, what is nothing but a big data from your thoughts?
So basically, big data is obviously, and I may be off out here, but
Okay.
anytime when we have a large amount of data that we are dealing with in terms of analytics and stuff like that, if we want to mine that, we want to get useful information out of that. I mean, that is what big data is.
Yes. Exactly the term that straightforward saying that the big data is nothing but if we have the data in large amounts of volumes of data, if we have just we call it as big data. But apart from that volumes, we have some other terms which will define this big data. So what are
Mm-hmm.
those things? We'll just go through all these things. From this session, you are going to learn this, what is big data, how to learn what are the challenges that are facing with this particular data. So here all these terms are just defining what kind of data that what we have. So one of the research done by IBM is saying that in the year of 2013, how much amount of digital data that we have is a 4.4 gigabytes of data in the year of 2013. An estimation has given for the year of 2020 that will increase to 44 gigabytes of data. So you can just convert it to how many GBs of data that we may have in the year of 2020. That's just assumption. And another assumption by the same company has given that in the last 2 years only, the 2 GB of data that has been generated. So you can just assume that the WhatsApp recently introduced, some other
Mm-hmm.
applications recently introduced, how much data that they are generating. That's nothing but we are just sending some messages, pictures, videos, and all those things. That's are not only the thing for the server that they are storing. They need to store everything that we are sharing, right? So that we can easily assume that the data that is generating every day, where that is storing, how they are storing the data inside their databases or storage devices. That's what the assumption, just an assumption that has been given. You can just assume that how many volumes of data that may be generated in the future. Is your devices, is your organization is capable of storing that particular data? If I have the storage devices, is your
Mm-hmm.
technologies that what you are using are able to process the data in an expected time? Why? Because if, for example, I'm maintaining a database that's okay, that have stored 4 GB of data, that's take up to storing. But I need to run a program in that particular 4 GB of data. Is the database will result you within the time that you require? Is that's a question that they are facing in the years of 2000, 2000, 1995 to 2003. But from this particular thing, what is achieved? What company has started the initiative and all those things will come in the next slide. So yes, as of now, as our definition is saying that it refers to the size. The single computer cannot hold, cannot process that particular data. We call it as big data. Yes, all these things we
Mm-hmm.
have discussed. But in a business perspective, how we can just define a big data is nothing but big data is a right-time business insight and decision making at extreme scale. By using this single definition, we can just define the entire Hadoop framework as well. Why? Because if we just take big data is a right-time business insight and decision making at extreme scale. At the right time, we need to take a better decision using large amount of data. The scale is nothing but if we have a large amounts of data, if we have a scale everything into our infrastructure, and from that we are getting some insight at right time when we need that particular thing. You got this point, I hope, right?
Yep. Yep.
Yes. What is a big data problem from this? You can just go through this particular question and you
Yeah.
can just.
Which of these would be considered to be big data? Order details for a purchase at a store, all orders across hundreds of branches nationwide, information about a person's stock portfolio, all stock transactions made on the. I think all of them, right?
If you just go through each and everything, order details for a purchase at a store. I buy a single product. How much
Yeah,
data
but
that
then
will generate?
exactly. No, it will not generate a lot of data, but you will.
Yeah.
Don't you need to, go through a lot of data to get that detail?
No, why we need to go to that lot of data to store a single particular order
Oh,
for
okay,
purchase?
okay, okay, okay.
That
I
will
took it the wrong
maybe
way.
generate that the product ID or the cost of that particular thing or the brand or all those things that need to store. But if we take the second option, all orders across hundreds of branches nationwide. If you just take Walmart example, how many
Mm-hmm.
purchases are there for a particular store? How many orders are there for each and every store? That will generate lot of data. For a second
Right,
or per minute only, that will generate lot of data. If you just see daily how much data that is generating for a particular thing. And the C option, if you just take information about a person's stock portfolio, that will also like a stock portfolio means your profile, how much your single person's profile, that's maybe that that not exceed any other big amounts of volume if you just take. But if you just take a D option, all stock transactions made on NYSE during a year, how much data that will generate. This data is freely available in the internet. You can just go through all those things also.
right. So,
Now,
so
because
Sindhu,
of
I have a
that,
question
yeah.
here. Basically, when you say all orders across hundreds of branches of nationwide, when you say big data, are you saying that how much data we are fetching, or are you talking about how much data is it going against?
Not against that volumes that I'm talking. How much data that is generating.
Okay, because see, when you say that all orders across hundreds of branches nationwide, order details for a purchase at a store. Order details at a purchase or for a purchase at a store is really a subset of all orders across
Yes,
the store, right?
exactly. Yes,
So
exactly.
I am basically in A, I'm just fetching one row of data, but to get that one row of data, I am probably going against billions of rows, right?
Yes, exactly. You are saying in a different perspective actually. Uh, just I want the data of a particular person, or I want to store a particular purchase detail in my database. How many fields
Right.
that may take? Yes, right. You got my
No.
point.
So Sindhu, again, my question is, the question was which of these would be considered to be big data, right?
Yeah.
Or what is a big data problem? I mean,
Yes.
the way I look at big data is anytime I have a huge amount of data, volume of data, it's mostly in a database or wherever, however it is stored, you know,
Yeah.
anytime I have to analyze or work through that, you know, I I'm talking about the big data concept really. I may be fetching one row of data, or I may be fetching millions of rows of data. But the point is that the fact that I'm going against such a big data set, that is what is a big data problem really. Would that be
Yes,
considered right or wrong?
exactly. Yes. Actually, exactly the big data problem is the large amounts of data if we have that cannot be processed with a single machine or that cannot be stored with a single machine is considered as big data. But if we come to this particular question, just the order details for a purchase at a store, that's a single purchase, how much data that will generate, all the orders across hundreds, how much data that will generate.
Okay.
You are just searching about if you just when you have a query like you have queried a database to get that result of a particular query, how many results to be scanned that you are searching, I think, like to
Right.
get one particular order. Here they are not bothering about storing and all those things or retrieving that particular data from a database. Just a one order, how much data it may take inside your, how much space it will occupy. That's what they are
Okay.
mainly dealing with.
Okay.
But if we just take it as the second option, how much space it will occupy to store all those hundreds of branches. Okay.
Okay.
Like the same C and D option also, like a controversy things, single person's profile and all the person's stocks made
Yeah.
across the
Yeah.
year. Okay. So clearly
Okay.
here they have just mentioned that in case of A and C, traditional RDBMS can easily handle. So that's what their
Mm-hmm.
main focus is. Like a single person's transaction, you can store it in a database. That's what
Yeah.
happened till now, right? In case
Yep.
of B and D, traditional systems really do start to struggle. I think you
Yep.
just have interacted with any RDBMS systems, right?
Yep.
Yes.
Yeah.
What are the limitations of an RDBMS system, or if you just take any other database? What
Yeah. I
are
mean,
limitations?
obviously, I mean, anytime you are basically trying to get a large query set, it takes time, right? Or it's a
Yes,
bottleneck. I
definitely.
mean, so yeah.
Yes. They cannot work with a distributed environment, right? They cannot scale horizontally. Are you getting
Right.
my point? Yes. Anytime, if, for example, you have a new data which is coming into your database, if enough space is not available, you just need to scale it up vertically so that it can handle the new data which is coming into. So, in case of, say, for example, you have a 10 GB of data which is to be introduced, and you can just add that hardware and you can just store it. But if you have a
Mm-hmm.
1 TB, 2 TB, 3 TB, like this daily, which is changing, which is coming continuously, is your database is able to store that much amount of data. Like if you just take these examples, all orders means for every minute, for every second, a new record will come into picture. Like if you just
Right.
take branch wise, maybe 1,000 transactions may come into picture and need to be stored. Is your
Mm-hmm.
database. That's what the example that they have given. Even
Yep.
though the single transaction also we can consider as a big data if we can see it as a whole. Like all the transactions if we see, that is a big data problem only, but if we just see the single transaction, that can cover with an RDBMS system. Okay.
Okay.
Yeah. The sources of big data, how the big data is generating, from where we are getting the big data. You can just simply take your mobile phone as a source of
Mm-hmm.
big data. How many apps that it holds. Every banking sector also have introduced their apps to be integrated with mobiles. So how the data is generating daily. Like if you just see the best example called Amazon.com, what they will do by using your information once from login session to logout session. What pages you have viewed, what projects you have looked at. Already this analytics has been implemented past years ago. What they have done is, say for example, the best example is when I go to YouTube and search for some Telugu movie or English movie, any particular movie, at the right side of your page, it will just give you recommendations. How it is
Mm-hmm.
giving. That's what the concept called recommendation engine or recommendation analysis that we call. What they are doing is the behind this entire things are going on of business intelligence, or also I can call or analytics, I can call it as. So the text that you have entered, they just go to their web pages or their data sources and refill your all those things with that particular thing and just project it over in the web page that what you are seeing. By having this kind of analytics tools implemented to your organization, definitely their business can increase. Say for example, in Amazon.com, I'm searching for a book, the Hadoop development book I'm searching for. Definitely you will get at the bottom of that particular search box all the Hadoop related things. The recommendations engine will call behind this your query and everything will be projected. Likewise, the problem is already there, but when the problem is coming is, say for example, my company has been introduced into the world called in the year of 2000. From the 2000 year to the year of 2015, say for example, in the first year, my databases are capable to store that particular data. Second year, third year, fourth year. Likewise, the data is increasing. Your resources to be able to capture your entire data for the next future years. That's what the problem that they are facing year by year. So they are planning to integrate any other tool which stores this large amounts of data, and when you query, say for example you are querying by using some book name, you are behind models which you are running, it should process it within a second. Otherwise, say for example, if it is taking say half an hour time to reflect it back, what are the related books are there in their store, can you wait for half an hour to get that particular data? No, nobody wait, right?
Yep.
Definitely
Yep.
we need it very fast, faster than a human being we need. So that's why they are just starving about the processing of data, and the first problem covering by the storage of data. The huge volumes of data, how they are storing, they are just covering each and every department, uh, how they are storing that big data and all. If we just take a single flight that has two wings, the two sides of that particular thing, each and every wing for a particular traveling, it will generate 20 TB of data. 20 TB, not even GBs we are talking about, just 20 TB. And it has two engines like that at two sides. And the measurements have been given here for a particular year which has 365 days, and how many flights are there for that particular city, only United States that they have taken, and the hours for each for how much frequent the flights are there, how many wings, how much data. So you can just see the figure here, how much data that will be generated in a year in a particular city, only United States. Likewise, how many flights that are there throughout the world, how much data, where that they are storing. Yes, like YouTube, LinkedIn, all these things are, we know very well. Why? Because as we are the sources of all these things, we will generate the data. But if we just take it as a figures, definitely those are challenges for the industry to store that much amount of data. All those things. Yes. Today's business analytics, what they are doing by using a transaction that you have made, by using some sentimental analysis on the data that you have for the end-to-end customers and the log files of particular machine, all these things that they are doing in this business analytics days. So from the point of view from the big data, what you can do in the future is that is listed over here in the next particular thing. Yes. Say for example, you have
one second. Can we just go back to the previous slide?
Yeah. Actually the same thing which has listed in terms of words. That's why I just did. Like multiple devices you are just getting from.
That's fine. Okay. We can move.
Yeah. Yes. For example, as we have discussed, a lot of data sources are available, and if we just differentiate everything into categories, so we are getting it from internet, we are getting it from mobiles, we are getting it from a single sources also. As I'm a single person, I am also generating some data. As an organization, I am also generating some data which is into digital marketing. So by having all those things, and we know the definition for the big data, that's a large volumes of data, there are some more terms which are coming into picture which will define your big data. So collectively, apart from the volume, we have some more features which will define all those features, all these things which we have just taken here as an example all the sources along with the characteristics that we are going to discuss, which will define your big data. Yes.
Mm-hmm.
Big data is more than just a size of data. 90% of world's data is unstructured data. Is your image file that you have uploaded into WhatsApp, is that is a structured data that you can call? Or an audio file that you are uploading, is it a structured data that you can call? What's a structured data
No.
actually? Right? Yes. When we can
So
able to define the schema for the data, right? Yes,
Okay.
yes, you can proceed actually.
No, that's fine. It's just you were saying that. So how would you define structured data?
Yes. If you are able to define some structure for the data that it is currently holding in that particular file or any other thing, we can just call it as a structured data. But
so why can't you define a image that you upload into your WhatsApp structured data, because it is a structure of an image, right?
Yes, it has a structure of an image, but can you just define that it has these many fields, it has these many rows, so that can you give like a database structure for that? Or can you query the data in a structured format, like select some columns from that particular thing?
Or is it like, because I cannot say that, okay, show me all the images that were taken on my birthday. I mean, you don't have that level of structure. Is that why it's not structured?
Yes. Like,
Okay.
for example, there is no direct analytical tool or direct interaction to that particular image or audio files or video files or JPEG or all those things. There is no particular tool which is giving direct interaction to get the exact data what is there in that particular thing. Is that you have? Again, we need to do some pre-processing to have that particular data into structured format. Like if we just take an image, that image in Hadoop, how we can is that image is converted into one particular format, which is a Hadoop format. That's a sequence file format. There, that's everything is a key value based. Say for example, you know that the image file or a particular thing, we just call it as a pixels, like x and y coordinates we are going to take into consideration, and from that you just do the analysis.
Okay.
Yes. Like whatever the data that you have, if you are able to define a structure for that, that's a data that you can call it as a structured data. And say for example, you have the text file. Say for example, the first line has a 5 words and the next line has a 10 words. Another line has some different lengths vary in for different rows. Can you define a structure for simply for the text file or for the PDF file? Can you just define? That's not possible, right? Why? Because of number of columns differing for one particular row is different, another particular row is different. That's where NoSQL databases comes into picture actually. When you go to the NoSQL databases, why they comes into picture? Why the industry needs NoSQL databases that will cover unstructured data concept also. There,
okay.
If we have even though if you have a different number of columns for each and every row, you can define your structure. That's a part of Hadoop only. Yes, 90% of world's data is unstructured. What do you mean by unstructured data, which is coming over here? Additional problems that are facing in this field. Most data is worthless and it is hard to find the usable parts. That's a one better thing that you need to find out. It's hard to gather the data. Data is created very fast. Data from different sources is in different formats. Yes, all these are problems, right?
Right.
When you're saying if you have a data, for example, my organization is storing data from the past 10 years. Is that entire data is worthful for me to get a better feature? No. Why? Because I'll say, for example, all the employees' data or all other things all the stuff has been stored. That is not at all useful. The entire information is not at all useful. Only some pieces of that data are useful. You need to get that particular thing. Say, for example, you have the 50 columns table that you have. From that, if you store entire 50 columns of your table into a select query or all those things into an analytical tool that you have integrated, if you just fetch all those things, your time will be wasted. You just need to find out what are the important columns which will define your problem statement. That you need to find out, you need to get it into your results. That's what from the data we need to find out which is useful part, which we can omit and all those things. And it's hard to gather the data. For a particular problem, what data that we need. Say for example, I'm doing log analysis or machine log analysis, we can call it as. For machine logs, how to find a machine which is going to be failure in the future, that I'm going to predict now. So for that particular thing, whatever the information that is needed, how to find that particular data, and if I know all these files I need. So for example, sometimes you don't have an access to get the internal details of your machine. At the time also, how you can gather your data for attaining your problem statement. And data is created very fast. This is what the main problem, main characteristics of big data it will define. Nothing but, say for example, you are doing a transaction from your mobile phone. Some bank transfer you are just doing, that will immediately reflect in your databases, right? That means within a seconds your database is getting updated. That's what data is created very fast feature. You may get my point.
Yep.
Yeah, that's only the single example. If you just take all the websites, social media, if you just take immediately whatever the message I'll post, they can able to see. And the second part is behind what is happening is that there is servers also storing that particular data. Say for example, if I just uploaded my profile pic or any other particular thing 10 years back, this date also I'm able to see that profile pic that I have uploaded 10 years back. That means the server is also storing that particular data, and the another person is also able to see my picture. That's what the data is generating very fast, and the hard to find the useful information from the data what we have. And the third problem, if we just take, data is getting from different sources, using different formats. Just for this particular thing, we can just take a best example. Say for example, in a particular data center, if like call center, if you just take, they want to give some training for the fresher candidates who have were recruited recently. How they'll just give training for the new candidates is nothing but one is in a text format. They'll just provide some basic documents to the candidates, and they'll provide some audio or video kind of information for the candidate. Whatever the things that are there in a video format, they'll just convert into text format and they'll just give it to that particular candidates. That means, say for example, you want to do some analysis on that particular thing. The data is there in image format, the data is there in video or audio tapes, and the data is there in text format. Or some you have given some problem statement called try to find out the users who have logged into Facebook from the time 8 o'clock to 9 o'clock. You just need to do some analysis. You need to know the candidate who is registered, what time he is registered, and all those names and everything, along with that log file. One is a log file, one is a profile file that they have in their servers. Like two types of formats that they need to deal with it to complete that particular problem statement. Likewise, when we are going for the complex problems, you just need to face different formats of data will comes into picture, and you need to face all those things. That's what the second problem of big data. Data is creating very fast, that too in a different formats. You just need to deal with all those things. That's actually a headache of a developer that need to take care, that they need to like actually lot of MapReduce program that need to be integrated for that. I faced that problem when I'm doing with a healthcare related domain when I have done 2 years back.
Well, what healthcare? Which one?
I'm currently working for healthcare domain.
Yeah,
So,
which company are you working for? Which or under healthcare? Which one?
yes, I'm working for UFG.
UFG.
Yes.
Okay, I'm also in the healthcare domain. That's why I asked.
Okay. Like a fraud detection kind of thing I have worked. So for that particular thing, the file format are different. So one file will come in a user profile will come in a one particular file, and the hospital's list will come in another file, and the doctor's information and the patient's information will come in another file, and the insurer information will come in another file. Like that, we just need to integrate, and we just need to come up with a single format for all those files. That's what problems comes into picture. As part of POC also, we can cover that kind of problem statement if you want it. So yes, these are all the big data problems. Apart from the volumes of data that we have, the same thing is explained here. Yes, the three ways of big data that are there here: volume, velocity, and varieties. The same, you can just define it now. The volumes that is growing day by day, velocity which is creating very fast, variety we are getting it different formats. Yes, all these things are this. That's why I have asked us what is there in your mind as a definition for big data. All these things you can just define it now. And apart from one more feature is also there that we will discuss now, and the volume just they are given in a pictorial format from the year of 1980 to 2013. How the cost is decreasing for a GB of data if you just see. Those are just the thing. I can just share this slide as well. And yes, when the capacity increases, now we can get it the devices very cheap compared to the earlier days, right? So that's why use your storage devices as you are getting it very cheap, and store as much as of you can store. Yes. Which of the data do you think the worth storing in your databases for analyzing? Worth storing?
Okay. Transactions, yes. Logs, you would also want to store to get just the different habits of the person. Business data, yes. Again, user data, images, documents, videos. I mean, I don't know if you're saying something, I think probably not, but user data, normally you would want to, right?
Yes.
Sensor data, again, if you're saying, I don't know if you would want to, but depends on the business problem. Again, medical data, you would need to. Social, obviously, because it gives you pretty much all of them, no?
Right. So, have you observed that it has covered all the departments?
Right.
The social media, healthcare, sensor, user-related data, user profiles, business,
Yep.
like a network kind of thing, and all the transactions, banking-related things. So, in each and every field, we are generating lot of volumes of data. So, that's where the problem comes into picture. All of them can provide useful information after storing, like each and every generating large volumes of data that just they are giving an examples. So yes, data varieties of data that are there, social networking, images, all those things, and how fast the data is generating. Yes, apart from the V's that we have learned, the volume, velocity, and variety, there is another V which will define your another feature for the big data called veracity. What do you mean by just veracity? Is nothing but, say for example, uh, I'm working in a research center. For example, say the satellite has taken a picture of entire the stars or whatever the picture that satellite has taken, that has forwarded into the research lab that is there here. And can you just assume that, or can you just assure that the image is very much clarity, that what the images that we are taking, that we can just we cannot guarantee that the image is 100% clarity or 100% assured image of star, right? You got my point or not? So for example, satellite has taken an image and which is there in our databases. Yes, from that you just need to find out the nearest stars. You find out the nearest path between all the stars and let me know the two stars which are almost nearest than any other star. To find out that particular, that's what the your problem statement which is ahead. That's a Hadoop problem, just take it. And from that particular thing, the veracity feature is explained or defined as your data which is incomplete or inconsistent or which has some noise. Like you can just compare it with the video files or audio files or any other thing which has a noise or incomplete data or inconsistent data which is not at all complete, means which is not giving in a direct thing to go with that particular data. Like for example, that's a blur image. From that particular point, satellite cannot take a better image than that particular image, than that particular picture that it has sent to us. From that particular point, it cannot take a better clarified picture. That's the only with the maximum possibility of that particular picture clarity. From that picture also, you just need to get an absolute value or an approximate value from that. You just use that particular picture, whatever that it has sent. Use that for your analysis and just give an approximate values which are which two stars are very much nearer. That's what the feature called veracity. If the data is inconsistent, incomplete, or which has some noise, so we'll get as part of big data. So you can just define big data is nothing but which has lots of volume, which consists of varieties of data, which is generating very fast, which satisfies the feature veracity, or which is incomplete or inconsistent or noisy data. From all the V's, we just need to generate value for that particular thing. Even though it is facing problem with all of the V's, we need to get some particular value. We need to get some revenue from that particular, we need to get some business from that particular thing. So the definition that we have discussed in the first or second slide, real-time business insight, decision making at extreme scale. All these features are driven by these four V's.
V's, yep.
Real time. That means the which is data is generating very fast. The real-time data analytics that we are doing. Business insight. From the different kinds of data, we are just getting a single insight. Decision making. So the veracity of data that we have. Extreme scale means scale horizontally. If you have large volumes of data, from all those things, get the data, whatever it is. Right?
Yep.
Yes. I think you might have heard of this in taking decisions or insight and all those things. But the problem here, the extra problem is the velocity and the volume that you need to take care. Yes. The challenges of data that they are going, actually this includes Hadoop framework also. When they are designing Hadoop framework, they have taken all those things into consideration, network issues, hard disk size or memory and the preprocessor and everything that they have taken into consideration, and they have faced all these problems, and the solution has been given having all these things in their minds. Yes. Your good name, please, Varun.
Yeah.
Yeah, Varun. For today, this big data introduction is a class that I have planned. So again, there's a CAP theorem. You know this CAP theorem, the database related thing, that is CAP theorem?
Nope. I should have, right?
Okay.
But I haven't.
Yeah. Actually, this is a different concept at all from the big data, but that is important to know at this point of time.
Okay.
So yes, we have taken around 1 hour, right? So yes, I have planned as a this class to complete it by 1 hour only. Yes, from the two more candidates also plan to join this class actually from tomorrow or day after tomorrow. I don't know. That's why for the two classes we'll go for 1 hour, 1 hour, and from the next class onwards we can take 1.5 hour
So
like
Sindhu,
that.
I was just hoping because tomorrow I may not be able to. Can we have the classes like morning USA morning time? Would that work for you?
Yeah, you just share your timings, your available timings to those candidates. They will schedule the meeting. Okay, that's okay for me actually. After 7:30 here in the Indian time. I said the
After
same, but yeah,
7:30 7:30 India time would be
no,
I mean
yeah, yeah,
9:30 10 o'clock US time, right?
10 o'clock. I mm, actually,
7:30
my
in the
phone.
evening you're saying, right?
Yes, yes, 7:30 p.m. I'm saying.
Okay,
Okay,
no. I
if
mean,
it is
I was hoping if it is like something like more like
at 8 o'clock or something like that, huh?
yeah, 7 or 8 in the morning. That is probably like more like 5:30 or 5:30 your time. That would be difficult, right?
Yeah, actually that's a working hours here.
Yeah.
Okay, yeah. You just share your. Is it not at all possible in the evening time for you?
No, evening time is fine. It's just that this week, actually, I may be busy. Next week it'll be easier. Like, I have some commitments this week. So,
Okay,
I mean, tomorrow I cannot have the class because tomorrow I have to be somewhere. Thursday I probably can have, but Friday again I cannot.
okay. We just do one thing. As I said, right, two more candidates also plan to join this particular course.
Mm-hmm.
So for tomorrow, I'll talk to the backend persons. So to stop this class for tomorrow, and meanwhile, you just share the timings. I'll talk to the person, and we'll work on this. Okay?
All right. Okay. And Sindhu, can you share some literature or some material with me so that I can kind of just go through in the meantime so that it doesn't break the
Yeah,
momentum?
for sure, yeah.
Do you have my
Uh,
email ID?
I don't have.
Should I give it to you or
Yeah,
does
you
it
can
come
just
from?
start it here. Actually, the candidate may share. That's okay. When you have any other doubts or for further communication also that will be useful, you just ping here.
Can I just enter my ID in the chat window?
Yeah, that's what I'm saying. You just ping
Okay,
here.
great. So I just sent my email ID. If you can send me any literature, that would be helpful for me to kind of just go through
Yeah,
and
sure.
stuff like that.
Actually, I work for some other institution. The names are their institution that the problem is coming over there. They just need to change those things. That's why I haven't sent. But if it is not at all problem for you, I'll just send it.
No, it's not a problem for me. I don't care.
Yeah.
I don't care whatever name is there. Honestly, it
Yeah,
doesn't
yeah,
bother me.
sure. If the flow is okay for you, Varun?
Yeah, this is fine. I mean, this is fine. Again, I'll be, and that's why, if I can kind of just brush up a little more before we read. This was,
Yeah,
right now, it was very elementary. A lot of that, what we did right now was, obviously, it was very intuitive from big data and it wasn't a problem. So it'll be good to kind of just jump into, like, when you were talking about this theorem right now, that would be something that I did not know would be useful. But, we can wait for some other time.
yes. Actually, that's a useful thing only wherever you go in case of storage and pricing kind of thing. Okay, we'll talk about that. Just ping here your email ID so that I can send it now.
Yeah, I did you get my? I did. Did you see it?
Oh, I haven't received. In the chat window, right? In the window
in the
that
chat
is
window. Oh, it says only to the organizer. Wait, let me.
to you just
Hadoop
do
development. What is
yeah,
your ID?
yeah.
Sindhu,
Hadoop development
Sindhu,
organizer.
Sindhu,
Yeah.
see whatever the content you send it to us, we will have
Okay.
some format. Okay, we will share it to
Okay. Okay.
the participants. Don't no problem. Okay.
Okay.
Mm.
Okay. 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 Thank you.
Varun,
Okay, all right, sure,
We will communicate to you. Okay, content
awesome.
and
All right, that's fine. Yeah, I would just say, yeah, okay, cool, that's fine.
yeah. Thank you.
All right,
Okay. Thank you.
Sindhu,
And
really appreciate it.
Varun, the classes will be the same time from next classes also the same time. Okay.
Actually, that's what I was talking to Sindhu, that tomorrow I may not be able to be there. Can
Just
we do it on Monday just to be fair? I mean, to be safe, I guess.
do one thing, Varun. Just revert to us with the timings when you.
Yeah, I will. Yeah, I'll talk to Rajesh. Okay, I'll speak to him and I'll send an email also.
You send it to contact@zoomtrainings.com.
Contact@zoomtraining.com.
Yeah. Contact
Okay.
at
All right.
zoomtrainings.com.
Not Rajesh, right?
Not even Rajesh also. Zoom. This is the generic ID which will be monitored by all of my employees. Okay. So
Okay. All right.
this is the generic mail ID. So that means everyone can have access to this mail ID. Okay.
All right. Cool.
Contact
All
at
right. Cool. I'm just sending it
zoomtrainings.com.
right now.
Okay.
Yep. I got that. Yep.
Thank you.
Thank
Okay.
you.
Thank you.
Okay.
Thank
Thanks,
you,
Sindhu.
Sindhu, and
All
thank
right.
you all.
Yeah. Yeah.